Hi guys, it's Mrs. Jaqua. It's Unit 8 pre-test. So I've put notes in here, and if you want to have notes for your test, you better take the notes that are in here. I will provide the unit table. I don't know how helpful that would be, but I will provide it for you on the test. Okay, let's start the pre-test. So use a ruler and a protractor to draw an arrow diagram for each quantity described. Include a scale on each diagram. Ready, set, go. Here's just our really cool grid. So what we're going to do is this is north, and we're going to go 60 degrees from north. And we're going to go 30 meters out. So that would be north, 60 degrees east. And so that's 30 degrees. So let's go ahead and put a little scale drawing on there. Equals 10 meters. Okay, that was a little bit long. Let's do this. Okay, so that would be, use a ruler, guys. Okay, 2, construction. Roland is pulling a crate construction materials with a force of 60 newtons, angle of 42 with a horizontal. Draw a diagram. So Roland's pulling a crate. So let's make a little crate. He's pulling the crate. This is 42 degrees. And he's pulling it with a force of 60 newtons. There's Roland. Okay, so there's our really cool diagram. Now the next thing that we want to do is we want to find the magnitudes of the horizontal and vertical components. So in other words, we want to find the vertical component and the horizontal component. So we're going to go back to our SOHCAHTOA issues. So this is going to be my adjacent, and this is my opposite. We'll call it my horizontal, my vertical. We'll call this one's my horizontal. So my cosine, 42 degrees, equals your horizontal over 60. So horizontal equals 60 cosine 42. Let's go ahead and use calculator. Let's go to Desmos. Launch the calculator. Make sure our calculator's in degrees. And let's do 60 cosine 42. And it's 44.59. So horizontal equals 44.59. Okay, let's find our vertical component. That's going to be sine 42 equals opposite over hypotenuse. So your vertical component is 60 sine 42. Let's go to our calculator. Let's change this word to sine. It's really cool that I can do this. And that's going to be vertical is 40.15. And we'll call it newtons. Okay. Pause, take notes. Okay, so here's where I'm going to use this PowerPoint is to put the notes up as I do it. Push pause and take notes if you need to, but let's work this problem. Okay, so find the component form of the vector and magnitude AB, which is given the initial points there. So the component form of the vector, let's do that first. We do negative 0.1 minus 1.8, comma, negative 3.8 minus negative 3.8. And this ends up being add the opposite, so this ends up being plus. And so this is negative 1.9, comma, 0. All right, so then what we want to do is we want to find the magnitude. Do we want to find the magnitude? Did it say find the magnitude? And magnitude. Okay, the magnitude is going to be this, which is going to be the square root of negative 1.9 whole thing squared plus 0 squared, which ends up being 1.9. So this is the magnitude. And this is component form. Cool. Okay, so let's look at this. This is adding, subtracting, and doing scalar multiplication on vectors. So if you need the notes, go ahead, pause, and take them. Otherwise, we're going to process through them. So this is how I work this problem because I like to work it this way. I'm going to do negative 1/2 x, not x, b, which is going to be negative 1 and positive 2. And then I'm going to do 2w, which is going to be negative 10 and 0. And then we're just going to add them. So negative 11, comma 2. There you go. Okay, so number 5, I'm probably going to be using with a unit vector. Now don't forget when I see this stuff, if I have a vector A, comma B, oops, and I want to know the magnitude, which is denoted by this, let's call this V. Then that is the square root of A squared plus B squared. Don't forget that. Oh, I meant to write that on the other thing. Let's go ahead and write it on the other thing. Okay. Let's go. Find the unit vector with the same direction as V. So we're just going to look at a unit vector. So let's go. So U will equal the vector V divided by its magnitude. So this equals vector V all over the square root, negative 5 squared plus 4 squared, which equals square root 25 plus 16. 25 plus 16 is 41. So then U equals negative 5 over square root 41, comma 4 over square root 41. We don't like that because we like to rationalize that denominator, so this equals negative 5 square root 41 over 41, comma 4 square root 41 over 41. So you should know how to rationalize the denominator at this point in your life. Alrighty, so let's go to this one. Dot product, an orthogonal. Okay, so find the dot product of U and V and then determine if they're orthogonal. They're orthogonal if the dot product equals 0. So looking at our notes on the left to find the dot product U dot V equals, hard part of this one is not, it doesn't equal that. It doesn't equal that. 8 times negative 1/2 plus 2/3 times negative 6. So it equals negative 4 plus negative 4 equals negative 8. I'm pretty sure I got that right. Okay, and no, not orthogonal. And orthogonal, by the way, means perpendicular. Really cool word, just means perpendicular with vectors. Okay, it's a special word for vectors. So these are going to be some notes for this next section. If you need them, pause and take them. All right, find the angle between the two vectors and to the nearest degree. So what we're going to do is we're going to know that cosine theta equals the dot product of u and v over their magnitudes. So let's plug in all of the numbers. So this is going to be 4 times 2 plus -8 times -5 all over square root 4 squared plus -8 squared square root 2 squared plus -5 squared. This is 8, 40, so it equals 48 over 64 plus 16. This is 4 plus 25 square root 70, 82 times 29. Okay, and at this point we're going to use our calculator. So we're going to use cosine inverse of 48 divided by square root 82 times 29 to find out what our angle is. Let's go to our calculator and make sure our calculator is in degrees. It's in degrees. Oh, did I click on it? Click on degrees. So let's do cosine. Let's do the arc cosine because it's in here. And 48 divided by square root 82 times 29. So it's about 10.2 degrees. Alrighty, there you go. Okay, so these are going to be our notes for our projection. If you need them, pause, take notes. Otherwise, we're just going to cruise. Okay, so the first thing with projection, let's kind of remind ourselves, the first thing with projection, we want to find which is W1. Then we want to find W2, and then you're going to write it U equals W1 plus W2. So that's what we're doing. We're going to first find that projection and use our notes for it. So projection, which is W2. Oh, just kidding, it's W1. Projection of U onto V is written as U dot V all over their magnitudes, then times the vector. Let's plug in what we have. U dot V is going to be -2, -3, plus -1, 4, all over square root 2 squared plus 1 squared times 3 squared plus 4 squared, and then our vector. Whoops. Let's put those numbers nicely. So this is going to be 6 minus 4. This is 5, 16. Nope, that's 25. So this is going to be 2 over square root 625. No, it's not. Yes, it is. No, it's not. 125 We're going to write it this way though. This is square root 125, but it can be written as 5 square root 5. And we'll multiply it by -3, comma 4. So our vector W1 equals, we want to rationalize that denominator too. So it's going to be -6 square root 5 over 25, comma 8 square root 5 over 25. Now we have to go find W2. And I need a lot of space to find W2, so we're going to go ahead and use our whiteboard. Hopefully it will work. So U equals W1 plus W2. W2 equals U minus W1. And let's plug in what we know. So U is -2, comma -1. W1 is -6 square root 5 over 25, comma 8 square root 5 over 25. We're going to create common denominators. This is going to be an ugly problem. We're going to subtract them, so W2 equals -50. Wondering if I screwed up somewhere. We're going to have to push pause. Hold on. And then it's going to be -25 plus 8, 5 over 25. Okay, and so then what we want to do, our final step, is writing this in unit, in this unit vector. I don't know if I can get it all on there. Oh, shoot, I lost it. Let's come back over here. Let's not come back over here. Let's come back over here. That's an ugly one. The one on your test isn't quite as ugly. So that's your answer. Sweet. Okay. So locate this graph. I need to do this. So get that. Okay. Locate the graph, and these ones, hopefully you know how to do. They're easy-ish. So on the x-axis, we're going to go over 4. 1, 2, 3, 4. On the y-axis, we're going to go back 7. 1, 2, 3, 4, 5, 6, 7. Then we're going to go up 2 on the z-axis. 1, 2. So here's our goal point. Okay, there we go. Okay, so that's probably going to be useful. Pause, take notes. Put those there in case they're useful. Oh, this one's going to be really useful. Pause, take notes. Find the component form and magnitude of AB. So the component form of AB is B minus A, negative 3 minus 5, 5 minus 2, 6 minus 3. And the component form will be negative 8, 3, 3. Bingo. So let's find that magnitude. Now the magnitude of it is going to be just, it's the same parts, but we're going to square it. We're going to subtract everything and square them. So that's square root 64 plus 9 plus 9. So that's 73 and 82. So square root of 82. All right, so how do we find the unit vector? We're going to take negative 8, comma 3, comma 3, all over square root 82. So what that equals, we're going to rationalize the denominators. Well, I don't know. We might not do that at the same time. Negative 8 over square root 82 plus, not plus anything, back, 3 over square root 82, 3 over square root 82. Rationalize that denominator. This gives us negative 8 square root 82 over 82, comma 3 square root 82 over 82, comma 3 square root 82 over 82. Now you can simplify that 8 and the 82. It would be 4 over 41. Okay, graph the point. The first thing that you want to do is you want to find out where negative pi force is. Negative pi force is here. That's where negative pi force is. And then we're going to go 3 on negative pi force. 1, 2, 3. There we go. Let's rethink that one. Negative pi force. And then we're going to go 3. 1, 2, 3. There you go. Okay, graph the polar equation of 240. Here's 240. Polar equation for 240 is actually this. That's the polar equation for 240. All right, so we're going to need trig tables. I will have trig tables on the test. None of the other notes will be on the test, but we may need our trig tables. Oh, we're going to need our trig tables. So if we want to work this problem, what I'm going to do is I'm first going to find out what cosine of 0 degrees is. So let's go over here and highlight it. Cosine of 0 is 1. Cosine of 30 is square root 3 over 2. I'm going to write those above it. 1 square root 3 over 2. Cosine 60 is 1/2. Cosine 90 is 0. Cosine of that one is -1/2. And negative square root 3/2. And this one's -1. And I just want to have a good guess. So let's go ahead and, okay, so there's the rest of my table. So if I have square root 3, divided by 2, that's approximately 0.866. And then what I'm going to do in this table below it is I'm going to then times it by 2 and add 1. So this becomes 2. So 0.866 times 2 plus 1 is 2.73. So then 1/2 times 2 is 1 plus 1 is 2. I lied on this first one. This is 1, 2, this is 3. That's 3. Okay, so if we have 0, then this is 1. And we have -1/2 times 2 is -1, so this ends up being 0. And then 150, so if I have negative 0.86666, oh, 66025 times 2 plus 1 equals -0.73. And then -1 times 2 is, I don't remember. -2 plus 1 is -1. So let's go ahead and plot our points. So these are our points. 0 degrees and 3. 1, 2, 3. 0 degrees, 30 degrees, and 2.7 something. And then this is 1 something. And 120 is 0. Oops, back up. 2, 1, 120 is 0. And then 150, we're going to go 150. Around 150, but we're going to go -0.73, which is about here. And then on this one, 180, we're going to go -1. So what we have so far is we have up and around, in and out. Okay, so that's a really cool graph. Then we're going to use symmetry to finish her off. Oops. Not out that far. Back up. All right, symmetry to finish her off. So we're going to come here. I'm not very good at graphing. Here we go. There's my beautiful picture. It's beautiful. Okay, so here's what we're going to need. Cool, push pause if you need to. Okay, find rectangular coordinates for each of the given pairs. Let's push pause for right now.